go. I got my Raspberry Pi put together. Got a nice power button on the back side there. Hey guys, and welcome back to the channel. Ty here, and welcome to Ty the Space. I recently factory reset my entire smart home. I wiped off everything, Google, Amazon, Apple, and my Home Assistant. I'm going to be rebuilding everything from scratch. So I'm going to be bringing you guys on the process of how I rebuild my Home Assistant. I'm going to walk you through step by step how I set up my Home Assistant. Alrighty, let's get started. Now that the installation of my Raspberry Pi is all done, the next step I'm going to do is to actually wipe off my hard drive and then load up Home Assistant. And if you're not familiar with Home Assistant is a local open source smart home control platform that gives you complete control over your smart home. You can set up automations, routines, you can do complex stuff. It works with so many different integration services, providers, companies. The power of Home Assistant is just insane. So I'm going to go ahead and get it all set up. When you want to get started with Home Assistant, the first thing you want to do is pretty much head over to their website. It's called the homeassistant.io, and you pretty much will find everything you need there. I've headed over to the getting started section there, and then it kind of specifies all the installation process, right? You can choose the install methods. There's you can buy the Home Assistant green, Home Assistant yellow. These are pretty much pre-bundled. They put the hardware together and then the software together, so you just basically plug and play solution. And then there's the Raspberry Pi options, and there's a bunch of other ones there. You have Mac OS, Windows, Linux. You can run this thing on pretty much almost any platform. It is so much flexibility. This is crazy. But since I'm using my Raspberry Pi, we're going to go to the Raspberry Pi section, and I have a Raspberry Pi 5 and I have at least 4 gigs of RAM. It does say 2, but I don't do 2 gigs. The installation here still specifies micro SD card. I wouldn't recommend using SD card. SD cards are generally unreliable. They fail. I used to use the SD card before I ended up switching to to this SSD, and I would have to replace the SD card at least 2 or 3 times every couple of months, right? I mean, you could think you're buying the highest quality of SD card and it just still wouldn't last as long as you expect. So I would say don't even bother with the SD card option. Just get yourself, an SSD with an enclosure. But then again, there are very specific SSDs and enclosures that will work, right? I can put links to the specific ones that will work as well down in the description. Not just any enclosure will work. So that's the only caveat there. So I'm going to go ahead and download the Raspberry Pi software right there. So we're going to download it for Mac because I'm on my MacBook. Now this is basically what we're going to use to image the SSD. So I'm going to plug my SSD into my docking station. We're going to select our device type as the Raspberry 5. Operating system, we're going to scroll down and go look for Home Assistant. We're going to go to other specific purpose. Then we're going to look for Home Assistant. There we go, Home Assistants and automations. And we're going to install Raspberry Pi 5. Choose our storage, that guy. Next, and then yes, we want to continue. And I'm going to authenticate. All we're going to do now is just sit down, wait, let it do its thing, and then we can take it over to the Raspberry Pi. So I've gone ahead and loaded up the Home Assistant onto the SSD. So the next step is to actually plug it into my Pi. So what I've done is I've plugged in my Pi into my Ethernet connection network right there because I want hardwired connection. And then I've also gone ahead and connected a mini HDMI display to a regular HDMI display so that the thing can pop up on my main screen here. Now, you don't have to plug it into an external monitor. The process should not happen automatically on the back end. But I just want to kind of show you guys what happens or what's happening behind the scene. And I'm going to plug it into power. Now, one of the major issues with Pi is power. If you don't plug in the right power supply into the Pi, you might run into troubles, which I already am. My power supply that I have is not enough for the Pi. So you can see it needs a 5 volts right there to power up, but I can bypass that by just pressing the power button on the unit so it can continue booting up. Alrighty, so I bypassed the power requirement error message. You can see it's running through its thing in the back end, nothing to really worry about. And there we go. Home Assistant is pretty much loaded up. Command line is all done, and I can reach it using either the IP address, or I can just use this URL to reach it. So we're gonna head over to the computer all over again. Alrighty, so the installation is complete now. Now we can just head over to our browser and type in the IP address of the Home Assistant instance. You can either just type Home Assistant.local using the domain name, or you can go by IP address. I'm just going to go by IP address because I can look up the IP address on my unified system. I can look at it right there, and I know what my IP address is. Type that and make sure you put the port number as well, and then that is right there. We're all set up and we can get started. I'm going to say I don't want to upload a backup or restore. We're going to start clean slate. So create my home, create a user account, create my password. Since Home Assistant is running locally, I can decide to put my address in there. I like to help out the developers, so I'll give them basic analysis. This kind of helps the developers with understanding the system, so I kind of like to help them out. And one of the benefits of Home Assistant is it automatically goes ahead and scans your entire network. I have put Home Assistant on my main network, which is where I consider my secure network, so it has access to everything in the house. Home Assistant is local, I trust it, I kind of have full control, so I put it in my more secured network. So over there we can see it has found my Android TV, Apple TV, cameras, Philips Hue, even right there the ZBT stick. Once you're logged into Home Assistant, you'll land onto the Overview tab. This is the main dashboard and it auto-populates with whatever is available. It can be customized later. We will come back to this once we have devices and areas all set up. Next up is the Map dashboard. It shows the location of tracked devices and zones, but it only kicks in once you've set up presence detection using something like your phone. By default, a home zone already is created. You can add more zones like work or gym and trigger automations based on your location. The Energy tab is where you'll monitor electricity usage, solar generation, water consumption, and gas consumption, as well as cost. It's blank at first, but once you've got sensors or smart plugs installed, this becomes a very powerful tool. Then you've got the logbook. The logbook is who's turned on what, when doors are open, who triggered which automation. It is perfect for sanity checking your system. The history dashboard gives graphs and trends for specific devices, which is super useful when fine-tuning automations or troubleshooting. Next up is the media dashboard. It has footages, audio files for custom voice announcements, profile pictures, even floor plans. Think of it like your media hub but inside of Home Assistant. Then there is the to-do list, and just as the name implies, it is just a list to do things like groceries or tasks. I personally don't care for this view, so I disable it by long pressing the hamburger menu and hiding it. The developer's toolbar is one you won't need immediately, but once you start creating automations or tweaking settings, then you might need this. The settings tab is your command center. You'll set up users, add integrations, manage updates, configure networking, and run backups here. Now, speaking of network settings, this is where you can set a static IP address. I personally use automatic mode in Home Assistant and set a static IP reservation unify, so my Raspberry Pi always gets the same IP address every time. If you use the DNS name of Home Assistant.local, then IP address is irrelevant. The DNS name will always point to whatever the current IP address is. But later down the line, when you start to get into more advanced things like using a proxy server or pointing services to Home Assistant, you don't want the IP address to change, as that could break those services. Unified DHCP Manager allows me to manage IP addresses of devices on my network through a single pane of glass instead of individually going to those devices and configuring them. If I need to make changes like, say, move it from one VLAN to the other, it is a straightforward process. The notifications panel pops up important stuff. Pairing codes and new devices needing integration will appear here. The profile icon at the bottom left corner opens user and device specific settings. These settings only affect the devices you're currently using. So if you're bouncing between your phone, tablet, and laptop, each one can look and behave differently, like setting different dashboards as the main dashboard. If you have a wall tablet, you can also set a different dashboard for that tablet here. I also always turn on the advanced mode because I don't like any settings being hidden from me. Home Assistant now lets you create automatic backups with no extra add-on needed. Head over to Settings, then Systems, then Backups, and you'll see the option to set up automated snapshots. You can choose the frequency that suits you. I set mine to create a backup once a week, backup before any update, and I also only set my retention to 5 backups. I enable everything except media and my share folder to be backed up, as this keeps my backup file quite small. The only catch though is the backups are stored locally on your Home Assistant hard drive. So if your storage hard drive fails, your backups are gone too. So to avoid that, I back up to my NAS instead by going to Manage Storage, then Add Network Storage, and I use Home Assistant Backup as the name, select the backup option, and then include the local URL to my NAS folder. I use NFS as I find that much faster than Samba. If you don't have a server, you can also download the backups at Major Milestone and store them somewhere safe like your computer or external hard drives. Before adding devices, there are a few add-ons I always install. I head over to Settings, then the add-ons, and then the add-on store. The very first one I grab is the terminal and the SSH. It is my direct line into the back end and it is perfect for manual installation. After installing it, I jump into the configurations tab before starting it up and plugging a password in. It's flagged as not recommended, but I enable SSH when I actually need it and turn it off afterwards. If you prefer a key-based access, you can generate one using your Mac terminal. Just type in the following commands into your terminal, generate your key and drop that into the field. Everything else I leave default. Once that's set, I hit the save button, then I start the add-on and then open up the web UI to confirm that it is active. Next up is the file editor. It is lightweight, fast, and perfect for editing YAML files right inside of the browser. I enable start on boot and show in the sidebar as I want it always running and easily accessible in the sidebar, and then I start it. Then there's HACS, the Home Assistant Community Store. This one unlocks all the custom dashboards, themes, and integrations built by the Home Assistant community. It's not in the add-on store, so I manually install it using the terminal we've installed earlier on. Plug in the command into the terminal, HACS gets downloaded, and when the script finishes, restart Home Assistant. Then head over to Settings, Device and Services, Integrations, and search for the HACS integration and add it. HACS connects to GitHub, so you need a GitHub account to be able to use HACS. You can also create a free account. So I authorize Home Assistant to access my GitHub account and it's good to go. Once it's done, HACS shows up in the sidebar and I get instant access to awesome community built stuffs like the Mushroom Dashboard customizations, one of my favorite dashboard customization add-ons. It gives you pretty cards for various functions, which we might explore a little bit later once we get into building dashboards. Samba Share is the last one I installed for now. It exposes Home Assistant like a regular computer network share, and I can connect to it and copy files to or from the Home Assistant box to my computer. Out of the box, you can only connect to Home Assistant when you are on your home network, either through its local IP address or using the homeassistant.local address. Now that's fine if you only control things at home, but I like full access anywhere in the world. There are 3 main ways to do this. The very first one is a VPN, that is a virtual private network. You can run WireGuard right inside of Home Assistant and connect using the WireGuard app on your phone. When you're away, you turn on the VPN for full encrypted access and it's as if you never left your home. Personally, I prefer to keep my Home Assistant box dedicated to just the Home Assistant, so I run the VPN elsewhere. I use the Unified Teleport VPN feature. It is ridiculously easy to set up. Just enable it in Settings, generate an invite link and send it to your phone, and connect whenever you're outside of your home. The second option is Home Assistant Cloud, also known as Nabu Casa. It's a paid service, but you get secure remote access without touching your router. Plus, Amazon and Google Assistant integration allows you to expose Home Assistant directly into them. I don't personally use this, but if you want something that works in under 2 minutes with zero networking headache, it is definitely a solid option to consider. The third option is port forwarding with a domain name. You can use a free service like DocDNS to generate a domain name for yourself that ends with a docdns.org domain, or go all in with your own custom domain, which is what I do. I also run Swag as a reverse proxy, so Home Assistant isn't directly exposed to the internet. This lets me use subdomains for other services like my Plex and Nextcloud server, all under one secure setup. And this method gives me a lot of flexibility and control, but it is also the most advanced, so I won't go into full details here. If you want a dedicated video on this, let me know down in the comment section and maybe I might make one. Now, before diving into adding devices, I take care of my areas, labels, zones, and my naming convention first. This sets the direction of my entire setup. How you organize your home in Home Assistant, how you name things would affect every automation, every integration, and every dashboard. In Home Assistant, floors let you group rooms together by level in your house, so areas like your kitchen or living room can be placed under a floor like a main floor or second floor. I begin with creating the floors first. I use codes for each of the floors and assign levels starting from 0 in the basement and all the way to 2 on the second floor. Rooms like my garage, staircase, outdoors don't get assigned level numbers because they're not part of the vertical stack of my home. After creating the floors, I proceed to create the areas. Each area starts with the code for the floor it is on. That keeps everything organized and easy to navigate. Labels are functional categories I use to group devices. They are not tied to location, they are organized by purpose. I have labels such as security, climate, motion center, Zigbee, just whatever function I want to group them as. With areas, labels, and zones set up, we can dive into adding devices and integration. Devices are the physical hardware like smart plugs, sensors, switches, cameras, while entities are controllable or readable parts of a device. For example, a smart plug device can contain entities like an energy monitor, a USB outlet, 2 outlets, and so on. Different manufacturers have their own integration, and that's usually the easiest way to bring their products into Home Assistant. Some devices support multiple protocols, so if a brand-specific integration doesn't exist, you still might be able to add that device using another integration. For example, a Reolink camera can be added using the Reolink integration or through the OnViv protocol integration. You can also go into the integrations page in Home Assistant to see a full list of supported integrations. Let's talk about connectivity for a second, because smart home devices don't all speak the same language. There are several protocols in play: Zigbee, Z-Wave, Wi-Fi, Thread, and Bluetooth. Each one has its own strength and ideal use cases. Zigbee is a low-powered wireless protocol built on the IEEE 802.15.4 standard. It is optimized for low data rates and long battery life, which makes it perfect for sensors, switches, and lights. Now, what makes Zigbee powerful is its support for mesh networking. In a mesh network, each device can easily relay data to other devices that double as a Zigbee repeater. So, the more Zigbee devices you have, the stronger and more reliable your network becomes. For example, I have Zigbee soil moisture sensors in my backyard and front yard that don't have enough signal to be able to get into my Zigbee hub. But by adding Zigbee smart bulbs to my exterior, I was able to bridge them over from indoor to my outdoor. But here's the catch: Zigbee needs a Zigbee hub, and different Zigbee networks can't talk to each other. So if you have multiple Zigbee hubs like Samsung SmartThings, Akara M2, and Home Assistant ZBT1 running separate Zigbee networks, they won't mesh together. The same principle applies to Thread and Z-Wave, which are both mesh networks as well. You want to keep the number of networks low and maximize the number of devices on each one to maintain strong coverage and reliability. In my previous setup, I used SmartThings as my Zigbee and Z-Wave hub and bridged all those devices into Home Assistant using SmartThings integration in Home Assistant. Now, that setup worked reliably well for the past 7 years, but the problem is it's not local. SmartThings is a cloud-based service, so if there's an internet outage, it takes down all of my devices and Home Assistant stops working with those devices. I recently picked up the ZBT stick to start centralizing everything and making everything completely local. And this stick supports both Zigbee and Thread, but I will only be using it for Zigbee. But you can use other Zigbee sticks, not just the ZBT1 stick. To set up the ZBT stick, I plugged it into my Raspberry Pi using the USB extension cable that came with it. That helps minimize interference from the Pi's USB port. It shows up immediately in the integrations panel and then I add it up. Once that's done, there are two add-on options to manage the Zigbee network: ZHA or Zigbee to MQTT. ZHA is Zigbee Home Automation, the Home Assistant's default. Now, while it sets up much easier and in a fewer steps, the ZBT to MQTT gives better flexibility to integrate to other platforms since I want to be able to export mine into SmartThings. And ZHA setup is as simple as adding the integration in the Integrations tab. Zigbee to MQTT requires more than that. It needs an MQTT broker to communicate with Home Assistant. Now, MQTT is a messaging system for smart devices, and Mosquito is a server that makes it work. So the Mosquito server add-on needs to be installed first by going to Settings, Add-on, and then the add-on store. Search for the Mosquito broker, install it, then start. Confirm it's running before moving on. Zigbee to MQTT integration isn't in the add-on store by default, so just like the HACS add-on, it has to be added manually. Go to Settings, Add-on, Add-on store, and click the three dots in the top right corner and select Repository. Add this URL into the repo and import it. If the Zigbee to MQTT doesn't show up right away, do a hard refresh or restart Home Assistant. And once it appears in the add-on store, click Install. After installation, open the web UI and select the Nabo Casa ZBT stick and submit. Check the logs tab to make sure it's running without errors. If you're using a different Zigbee stick, you can go to Settings, System, Hardware to look up the port that the Zigbee stick is connected to, and you can use that to set up your Zigbee stick within the Zigbee to MQTT. Once it's running, click Open Web UI to start pairing devices. From here, I can pair Zigbee devices, rename them using my naming convention, and monitor the Zigbee mesh. Head back to the integrations dashboard to add the MQTT integration so Home Assistant can receive the message from Zigbee to MQTT. This same method allows me to retransmit the messages to other platforms, and it's all local within Home Assistant. And then there's Thread. Thread is a newer protocol also built on the 802.15.4 protocol like Zigbee, but it is IP based, meaning it can talk directly to the internet unlike Zigbee devices. It also supports mesh networking and is designed for low power devices. I've set up my Apple Home to manage my Thread network. The Thread network uses a Thread border router instead of a hub like Zigbee and Z-Wave. And although the ZBT stick can act as a Thread border router for the Thread network, I prefer using my Apple devices instead. The Apple TVs and home ports can act as a Thread border router, and they allow other Thread border routers like my Nanoleaf, Akara M2, and Nest Hubs, and even Home Assistant to participate in the network. But this has to be set up first before adding other Thread border routers, so that way they join the existing network. Else, those Thread border routers will just create their own networks if they don't see any existing one. Although in my testing of Amazon and SmartThings Thread border routers, I found out that they won't join any existing network. They create their own, so I have them disabled as I do not want to have multiple Thread networks. Apple doesn't give you a way to view the Thread network directly, but the Thread integration in Home Assistant does. It shows all active Thread networks and border routers, which is super helpful. Z-Wave is similar to Zigbee in that it's low powered and supports mesh networking. It operates on a different frequency, which helps avoid Wi-Fi interference. Z-Wave is known for its reliability and range, but it's more proprietary and device compatibility can be more limited. I've used it in the past, but I've leaned more heavily to Zigbee for simplicity and broader support. Wi-Fi is everywhere and it's great for high bandwidth devices like smart speakers, streaming apps, but it's not ideal for low power devices, especially when you have a lot of them around. Unlike Zigbee and Thread, Wi-Fi doesn't support mesh networking devices. It relies entirely on your router or access points. Now what that means is coverage and reliability depends heavily on your network design. I use Wi-Fi for devices that need constant internet access or data stream, things like video doorbells, smart displays, and appliances, but I avoid it for sensors, switches, or lights. They are better suited to protocols like Zigbee and Thread, which are built for low power, low bandwidth communication and can self-heal through mesh. Too many Wi-Fi devices leads to network congestion and can start to impact your primary devices like your mobile phones. Also, Wi-Fi doesn't offer native local control for most devices unless you use something like ESP, which I use with my connected garage door opener, or Tasmota, which you can do for some of the 2-year smart switches. Many Wi-Fi devices are cloud dependent, which can introduce latency or reliability issues if your internet goes down. Bluetooth Low Energy is useful for short-range, low-power devices like smart locks. It's not mesh capable and coverage is limited, but it is handy for direct pairing and onboarding, especially for Thread devices. Matter is the newest standard, not the protocol itself but an interoperability layer that runs over Thread, Wi-Fi and Ethernet. Its goal is to unify the smart home ecosystem. A Matter certified device can work across Apple Home, Google Home, Amazon, SmartThings and Home Assistant using either Ethernet, Wi-Fi or Thread. Matter and Thread are still developing. They've got potentials, but reliability isn't quite there yet in my experience. Still, they're still part of the connectivity options I use to bring devices into Home Assistant, just like Zigbee, Z-Wave and Wi-Fi. If a device supports Matter and fits the setup, I'll use it. For Matter devices, I use the Matter integration in Home Assistant. Most Matter devices support QR code onboarding. I use Home Assistant as the Matter commissioner. On iOS, it will default to using the Apple HomeKit app for the commissioning process. If it's a Thread device, the device will join the Apple Thread network. Once added, same process, rename it, assign it to an area and verify connectivity. Another integration I rely heavily on is the HomeKit bridge. This lets me expose Home Assistant entities directly to Apple Home. So even if a device isn't natively supported by Apple like a Zigbee sensor, I can still control it or view it through my Apple Home app. To install it, search the Apple integration, select HomeKit bridge, then choose the domain to include, which is basically entities to expose. Lights, switches, sensors, scenes, even scripts. I usually split them into multiple bridges based on their entity. Light and switches, cover entities, cameras. That keeps things stable, manageable, and prevents Apple from getting overloaded. After submitting it, it generates an HomeKit code which you can find in the notifications section. Scan it with your HomeKit app on your phone and go through the process of adding, renaming, and assigning it to rooms. The HomeKit bridge gives me seamless Apple ecosystem access without compromising the flexibility and control I get from Home Assistant. Once all your devices are in and organized, you're ready to move into automations. Go to Settings, then Automations and Scenes, and select Automations. This is where all of your automations live. In the bottom right corner, you'll see Create Automations button. Click that and you'll see the option to either create a new automation from scratch and your list of available blueprints. A blueprint in Home Assistant is basically a template for automation. Instead of you building an automation from scratch every time, someone can create a blueprint, a pre-made recipe basically, and then you just fill in the blanks like choosing which light, which motion sensor, or which time of day to use. If you want more options, click on the Discover More Community Blueprints. That takes you straight to the Home Assistant Blueprint community where you can browse and import new ones. One of my favorite blueprints is the Sensor Light Blueprint by Blackie. I've used it for many years now and it has so many options, but that can also make it a little bit complicated too. For example, I want to apply the following automations to my kitchen. I want the light strips to stay cool during the daytime and then change to warm at night. I also want them to only dim at their current temperature during the daytime, but at nighttime, I want them to dim to a warm temperature for ambient glow when no motion is detected, and then slowly brighten up to 4000 Kelvin when motion is detected in the kitchen. The blueprint makes all of that possible. I start by setting my trigger as my Aqara presence sensor. I set a 5-minute delay which dims after 5 minutes of no motion, and then I enable the use of brightness option, set the brightness to 100% when motion is detected for during the daytime, then I enable the color temperature and set it to 5000 Kelvin. For dynamic lighting, I let it follow the sun elevation with a range from 3000 Kelvin on the warm end to 6500 on the cool end, and under the night light I enable the light and set maximum brightness to 50%. Then I enable the night glow option and set it to 20% brightness and temperature of 2700 Kelvin. There's even a bypass mode. So if I'm cooking and I don't want the lights to dim or I want all the lights bright, I can use my kitchen light as a trigger to enable bypass mode. When that's enabled, all of the automations gets disabled for that time period and it automatically re-enables after a set period of time, or I can actually use the switch again to disable the bypass mode. You can build out lighting for this for every room or dive deeper with community blueprints for even more flexibility. And remember, you're not limited to just lights alone. You can use automations to trigger scenes, run scripts, send alerts, or control almost anything in your smart home. Scenes, scripts, and helpers are tools that let you build smarter routines, reuse logics, and keep your automations clean and modular. Scenes are snapshots of your device state. You can define how you want multiple devices to behave, save that state, and then activate that exact same state using the scene with a single command. For example, I created a scene in my media room called movie mode. It sets the light strip to an off mode, sets my bind to closed mode, and my receiver to an on mode. I can trigger scenes manually or through automation or even with voice assistance. Now, scenes are great because they are declarative. You can define the end state and Home Assistant handles that transition. Unlike scenes, which just set the state which is fixed, scripts are a little bit more dynamic. They can include delays and conditions. Scripts are useful when you want to chain actions with timing or logic.
Good evening. The house is settling into evening mode. Let the cozy night begin.
You can call scripts from automations, dashboards, or even other scripts. Helpers are virtual entities that store values or state. They're not physical devices, they are logical tools. I use the group helpers to group multiple light bulbs or LED strips in my kitchen together, or group multiple motion sensors together so they act as one, so something only happens if either of the sensor or both of the sensors detects motion. Helpers are also super useful for building conditional automation. For example, I use an input boolean called away mode. When it's on, certain automations behave differently. Or I use an input number to control dimming levels dynamically. They also make your dashboard more interactive. You can expose helpers to the UI and let users control logic without touching the backend. Scenes and scripts and helpers are what take your setup from reactive to intelligent. They let you abstract logic, reuse components, and build routines that feel natural. Next, we go into dashboards and UI customization. Once your devices and automations and routines are all in place, it's time to build a dashboard that actually makes sense. Something that's not just functional but intuitive for anyone using it. This one is a personal preference and can be as simple or as complicated and detailed as you want. Home Assistant uses Lovelace for its UI, a flexible card-based system that lets you build custom views. You can create multiple dashboards for different users, rooms, or use cases. You can either start from scratch, use a default dashboard, create areas amongst others. You can customize this to your preference. There's so many examples that you can try out online and try to replicate or try and create your own. And that right there is my full Home Assistant rebuild. We started by reorganizing the areas and devices, then setting up automations and blueprints, and now the system is up and running. Dashboards are not fully set up yet because my primary dashboard is my Apple HomeKit. My wife refuses to use the Home Assistant app, so all of the automations will only be living on Home Assistant and we will be using Apple HomeKit as our interface. Later down the line, I might decide to build a custom dashboard, but for now, Home Assistant works the way I want it to work. If you want me to dive deeper into automations, blueprints, or advanced routines, let me know down in the comment section. Your feedback will help me decide what to cover next. And thank you for watching, and I'll catch you guys in the next one. Ty with Ty the Space. Peace out.